Hi, today's video is about lipids. Another term that we use for lipids is fats. So the title of our notes is going to be lipids, and sometimes we call them fats. They're the same thing. And so the point of today's video is about talking about the structure of lipids and the function of lipids. So the molecular structure of lipids are made up of two parts. So lipids are made of two parts, and those two parts are called monomers. Okay, so the pieces are always called monomers, and the first part is called a glycerol, and I'm going to draw that for you. So a glycerol is a piece of the lipid that has three carbons in them. So here's 1, 2, 3. Okay, and so each of these carbons is bound to an oxygen and bound to hydrogens. Okay, so this whole thing is considered a glycerol, and it is one part of a lipid. So let's name that. So this is a glycerol. And the second part is called fatty acid tails. Okay, and the fatty acid tails look like this. So I'm going to draw those orange. And so it is a carbon attached to another carbon, and this carbon is bound to two hydrogens, and this carbon is bound to another carbon that has two hydrogens. And this carbon is bound to another carbon with two hydrogens, and it goes on and on. It is a long chain of carbons that have two hydrogens on each one, and it's just bound to lots of carbons. So it's a long hydrocarbon chain. And each fatty acid tail has about 20 to 30 different carbons, okay? And it goes on and on. And so sometimes we just draw it like a zigzag line like this. And what the zigzag line means is that each bend in the line stands for a carbon, and each carbon has to have four things bound to it. So if it is bound to another carbon, to two other carbons, so let's look at this carbon here. It's bound to this carbon, two hydrogens, and this carbon. Okay, so we're going to call this a fatty acid tail. And so those are the two parts of a lipid. And so what happens is these two parts have to come together in a dehydration reaction. So let's write that down. So the two parts come together in a dehydration reaction. Okay, and so what we then get is we have a glycerol that looks like this. Okay, I'm just going to draw the carbons for now, but just know that all the carbons are attached to other things. And then there's some oxygens attached to each carbon. And then for this particular lipid, which is called a triglyceride, so I'm going to write that here. Triglyceride is this example. Each carbon has one fatty acid tail on it. So I'm going to draw it like this. So on this oxygen, we have a carbon, 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 and it keeps going all the way down. And like I said, there's about 20 to 30 different carbons for each fatty acid tail. And this triglyceride lipid has 3 fatty acid tails. Okay, so I'm going to add over here that there are 20 to 30 carbons per tail. Okay. Okay, so this is called a triglyceride. And so what I would like to point out is that in this triglyceride, each carbon is attached to two hydrogens. Okay, but this is not always the case. Sometimes between two carbons, there could be a double bond, and you would lose 2 hydrogens. Let me show you. Okay, so just an example. Let's say, let me draw an example over here. So let's say I have a carbon attached to another carbon. This carbon has 2 hydrogens. This carbon has 2 hydrogens. This carbon has 2 hydrogens, and so on. Okay? So this is just an example. And then I'm just going to draw the zigzag to represent that it keeps going. Let's say that this carbon double bonds to that carbon. So there's 2 bonds there. So because each carbon can only be bound to 4 different things, it has to lose this hydrogen here. Okay? And it has to lose one of these hydrogens because each carbon can only have 4 things. So this carbon is bound to that 1 hydrogen, another carbon, and then there's 2 bonds for this carbon. This carbon is bound to that carbon, this hydrogen, and it has 2 bonds to that carbon. So sometimes this happens. And when this happens, it loses hydrogens. So if a fatty acid tail has all the hydrogens, like we see here, that is called a saturated fat. So let's write that down. Okay, so when a fatty acid tail has all its hydrogens, and so what that means is that there are no double bonds between carbons, it is called a saturated fat. Okay, so I'm going to put that definition here. Saturated fat. Okay, is when a fatty acid tail has all its hydrogens because it's saturated with hydrogens. If there are double bonds form between carbons, that is now called an unsaturated fat. Okay, when there are double bonds between carbons and it loses some hydrogens. Okay, so it is not saturated with fats. So a couple of things that I want to point out is that a saturated fat, because the legs, so these are like legs, right? So this is a lipid right here. This is the top part, which is the glycerol. This is the bottom part, which is the fatty acid tails. Those are the 2 parts of the lipid. When the legs are straight up and down like this, it is called saturated. And because they're straight up and down like that, all the lipids can line up in a really tight way where there's not a lot of room and they're just kind of like sardines all tightly in a row. So I'm going to draw a picture of that. Okay. So let's say saturated fat is like this. So I'm going to just draw a circle for the glycerol part, and I'm just going to draw straight lines for the fatty acid tails just because we're just saving some room. And so when the legs are straight like that, the fats or the lipids can get really close to each other and there's just not a lot of room for movement. So what that means is that at room temperature, these fats are solid because there's just not a lot of room to move. So they're really tight like sardines, and so these are solid at room temperature. So an example of this would be your butter. So solid at room temperature. An example is butter. Butter is a saturated fat. Saturated fats are worse for you than unsaturated fats because they can plug your arteries and cause heart attacks. So butter is delicious, definitely, but you don't want to eat too much of it. Okay, you should definitely have some because, you know, you got to enjoy your life, but don't eat too much. Okay, so the other one is unsaturated fat. And these look like this. Okay, so we have the glycerol head, and then we have legs. Oops, let me move that here. Let me move this over so we can see. Okay, and then we've got these legs that actually kick up because of that double bond. When that double bond is created, it changes the shape of the leg so that it moves up. Okay, so now there's a kink in the fatty acid tail. Okay, so let me draw another leg. So this one's kicking up, and this one's kicking up. Okay, and then so now they're kicking each other. The different lipids are kicking each other, which is creating some space in between them. You see this? So they're like dancing around, kicking up their legs, dancing, and there's space between them. They can't get all together like they can with the sardines, with the saturated fat. So because they have these legs that are kicking each other and making space in between them, this is a liquid at room temperature. Okay. And an example with this would be oil. And so these are your oils. So oils are fats, and unsaturated fats are healthier for you. So the oils are healthier than the butters. Okay. But again, you don't want to have too much, because anything that's too much is not good. Okay. So that is a saturated fat and an unsaturated fat. I want to introduce one more example. And this example of a fat, of a lipid is an important one for us, because this one is important in biology, and it is called a phospholipid. Okay, and let me draw it for you, and then we'll talk about its structure, and then we're going to talk about its function. Okay, this is important for biology. So a phospholipid has the same glycerol head. I'm just going to draw it like this. I'm going to draw it like this. Hang on. So we have the 3 carbons for the glycerol. So let me just draw that here. This is the glycerol. Oops. And all 3 of the carbons have an oxygen on the bottom. And on the top here, we have what we call a phosphate group. Okay. And so it's a phosphate with some hydrogens and oxygens attached to it. You don't have to know the details of it, but you do have to know that this is a phosphate group. So I'm going to put phosphate group. Okay. So I'm just going to put an arrow here. Okay. Oops. And so this phosphate group is attached to the 3rd carbon in the glycerol. And then the phospholipid has fatty acid tails, and almost always it has a double bond. Okay. So I'm just going to put it like this. Okay. So it's kicking up because it has a double bond here. That's a double bond. Let me redraw that real quick. So I'm going to draw a zigzag line. Each bend stands for a carbon. And then I'm just going to put a double bond here so you can see that it kicks up. Okay. So let's put this middle one as straight. And then we're going to make this one bend up, and it kicks out like this. Okay. Because there's a double bond here that causes a kink in the leg. Oh, I'm sorry. So in a phospholipid, there's only 2 fatty acid chains, not 3. And triglyceride has 3. A phospholipid just has 2. So a phospholipid looks like this. There's a glycerol. This is the fatty acid chains. There's only 2 fatty acid chains. And then there's a phosphate group on the 3rd carbon instead of a fatty acid chain. So that's what a phospholipid looks like. So I want to point out some properties of this phospholipid. I'm going to draw it like this. So I'm just going to draw the glycerol part like as a circle, and then I'm going to draw the legs like this. Okay. But just so you know, the fatty acid tails are a long string of carbons and hydrogens, and there's double bonds in some of them, so that causes them to kick up. And so phospholipids usually are oily at room temperature. And so some properties of this phospholipid is that the head part is called a polar head, glycerol head, and the polar head is hydrophilic, which means that it is water loving. Okay, so that's the glycerol of a phospholipid loves the water. And then on the bottom, we have the fatty acid chains. Okay, so these are the fatty acid tails, and these are hydrophobic, which means water hating. Okay, so we have this molecule, a lipid, a phospholipid, and it's got a head and some tails, and the head part loves the water, but the tails hate the water. So imagine what would happen if you put like 1,000 different phospholipids in a cup of water. What do you think would happen to those phospholipids? How would they react, do you think? What happens is all the heads, oh, hang on, let me draw this for you. This is what happens in a cup of water. So let me draw a big cup. Okay, so this is a cup. We're going to have some water in here. Okay, and we're going to write when phospholipids are in water, they form this configuration. What they do is, I'm just going to draw it here since I have room. The heads all come together because they love the water. Okay, and they form a circle. Okay, so I'm going to draw this. I want you to draw this in your notebook too. They form a circle where all the heads are on the outside. Okay, and then what happens is all the tails are on the inside of that. But there's water on the inside of this also. So what ends up happening is you have another layer of phospholipids with the heads on the outside touching the water because it loves the water. Okay, I'm going to draw in the tails in a second. Okay, and then the tails are going to be all facing each other. So I'm going to draw the tails like this. I'm just drawing them straight lines right now because I'm drawing a quick drawing. But you need to imagine that these tails are kicking each other. Okay, and so this is an oil. So all the tails are facing each other and all the heads are touching the water. And that's because the tails hate the water and they don't want to go anywhere near the water. So this is what automatically happens when you put a bunch of phospholipids into some water. And so why this is important for biology is because this is what a membrane is. And a cell, which all living things are made of, are always have a membrane covering. Okay, so it's like the skin of a cell. And some cells have structures on the inside of them. And those structures on the inside are called organelles. And those organelles also have a membrane. And membranes always look like this. Okay, so this could be a membrane of a cell. And so we're going to write this down. But all membranes, let's change colors here. All membranes are made of 2 layers of phospholipids with the glycerol heads on the outside and the inside. And the fatty acid tails facing each other, okay, where there is no water. So I'm going to add to this picture that we have water here. H2O is here, and there's H2O out here. Okay, so there's water on the inside, water on the outside. There is no water on the inside here. So let's write that down here. No water. Okay, and this membrane has a special name. It is called a phospholipid bilayer. Okay, and all membranes are made of that, including the membrane of the outside of the cell and all the organelles inside the cell. Okay? Okay, so that's it for today. Have a great day. See you next time.